I want to tell you about the first time I traveled to Okinawa as a practicing physician. I had been working in preventive medicine for over 2 decades at that point, and I had seen enough elderly patients to know what aging looked like on paper. I knew what the blood work of a 75-year-old was supposed to show. I knew the expected range of inflammatory markers, kidney filtration rates, blood pressure readings, cardiovascular risk scores. I had internalized those numbers across thousands of patient files over 20 years of clinical practice. Nothing I had seen prepared me for what I found when I reviewed the patient records in Okinawa. My name is Dr. Kenji. I have spent more than 4 decades in preventive medicine and longevity research in Japan. And what I am about to share with you is not drawn from a textbook. It is drawn from what I observed directly in clinical files and in patient consultations in a population that ages in a way that does not match the medical expectations we carry in from the outside. The files I reviewed in Okinawa belonged to men and women in their 80s and 90s. Some were over 100. And what those files showed was not what those ages are supposed to produce. Inflammatory markers that belong to people in their 50s. Kidney function readings that a Western physician would consider unremarkable in a 50-year-old. Blood pressure profiles that did not require medication in individuals who had been living for 9 decades. Cognitive assessments that showed retention and processing function well beyond what standard geriatric medicine would predict. I sat with those files for a long time. The explanation I kept encountering from researchers, from local physicians, from the patients themselves when I spoke with them, was not genetics. It was not a single supplement or a single habit. It was the plate. What these people had been putting on their plates in a specific combination every single day for the entirety of their adult lives. There is something on the Okinawa plate that most of the world has never examined closely. Not just what is on it, but what those specific foods do inside the body after 60, when the biological processes that drive aging begin to accelerate, and when the nutritional decisions made in previous decades either pay off or reveal their damage. That is what I want to examine here. Not as a cultural story, not as a travel piece about a beautiful island, as a clinical question with a clinical answer. What is on the Okinawa plate, and what does it do inside the aging body that standard Western nutrition does not? Before I go further, if what you are about to hear shifts the way you think about food and aging, even slightly, this channel is worth your attention. I do not share recycled wellness content here. I share what 4 decades of clinical observation have produced. Subscribe and stay with what comes next, because the information in this video builds progressively, and each piece connects to the ones that follow. Now, let us start at the foundation, because the Okinawa plate begins with a food that most Western nutritional frameworks have either overlooked entirely or fundamentally misunderstood. For most of Okinawan history, and specifically during the decades that produced the generation of centenarians that put this island on the map of longevity research, the primary source of daily calories was not rice. It was not bread. It was not any of the carbohydrate staples that form the base of most other dietary cultures, including mainland Japanese cuisine. It was purple sweet potato, murasaki imo, a dense, pigment-rich root vegetable that provided the majority of caloric intake for traditional Okinawans across generations, and that behaves inside the body in a way that is fundamentally different from the carbohydrate sources that most people over 60 are currently consuming. To understand why this matters, you need to understand what happens in the body every time a high glycemic carbohydrate is consumed. When you eat white bread, refined pasta, white rice in large portions without fiber, or any processed grain product, glucose enters the bloodstream rapidly. The pancreas responds by releasing insulin to move that glucose out of the blood and into cells. This is a normal and necessary process. The problem is not the mechanism. The problem is what happens when this spike occurs repeatedly every day across decades, and specifically what it does to a body that is already past 60 and has already experienced a natural decline in insulin sensitivity. After 60, the body's ability to respond to insulin becomes progressively less efficient. Insulin receptors on cell surfaces become less responsive. The pancreas must secrete more insulin to achieve the same glucose-clearing effect. And in the meantime, the glucose that remains elevated in the bloodstream for longer periods after each meal does damage that is not immediately felt but that accumulates structurally. It binds to proteins, a process called glycation, altering their shape and function. It glycates collagen in arterial walls, making them stiffer. It damages the filtration membranes in the kidneys. It affects the myelin sheath around nerve fibers. It accelerates the aging of the endothelial cells that line every blood vessel in the body. The HbA1c test measures the cumulative result of this process over 3 months. But the damage itself happens meal by meal, year by year, in ways that most people do not feel until the structural consequences have already become irreversible. Purple sweet potato does not produce this response. Its glycemic index is significantly lower than white rice, white potato, or refined bread, meaning glucose from Murasaki Imo enters the bloodstream slowly and at a lower peak, producing a modest, sustained insulin response rather than a sharp spike. Part of this is due to its fiber content, but a more significant part is due to its anthocyanins, the compounds that produce its distinctive purple pigment. Anthocyanins are not simply colorants. They are biologically active molecules that inhibit alpha-glucosidase, an enzyme involved in carbohydrate digestion, which further slows glucose absorption after a meal. They also directly improve insulin sensitivity at the cellular level, meaning the body needs to produce less insulin to clear the same amount of glucose. And they suppress specific inflammatory signaling pathways, including the NF-κB pathway, which is a master regulator of inflammatory gene expression in the aging body. What this means in practical terms is that a body fueled primarily by purple sweet potato is operating in a fundamentally different metabolic environment than a body fueled by refined carbohydrates. The insulin exposure is lower. The vascular glycation is lower. The inflammatory signaling triggered by post-meal glucose spikes is suppressed. And over 10 years, over 20 years, over a lifetime, the structural difference in arterial walls, kidney function, and neurological tissue between these two bodies becomes measurable, clinically visible, consistent with exactly what the patient files in Okinawa showed me. For viewers in Western countries, purple sweet potato is becoming increasingly available in Asian grocery stores and through online suppliers. It can be roasted, steamed, or prepared in any way that conventional sweet potato is prepared. Conventional orange sweet potato is a meaningful improvement over white potato or refined grain staples. It shares some of the low glycemic and antioxidant properties of Murasaki Imo, though the anthocyanin content is substantially lower. The practical transition is straightforward. Replace the white carbohydrate base of your meals, the bread, the white pasta, the white rice, the white potato, with purple or orange sweet potato as the primary caloric foundation, not as a side dish, as the base, the same role it occupied on the Okinawa plate for generations. Now I want to address something that is almost always misrepresented when people outside Japan discuss Okinawan diet. The assumption is that traditional Okinawans were vegetarian or near vegetarian, that the longevity of this population was produced by the absence of meat. That assumption is incorrect. And understanding why it is incorrect is important for understanding how the Okinawa plate actually functions as a nutritional system. Traditional Okinawans did consume animal protein. Specifically, they consumed pork in small quantities prepared in specific ways as a consistent element of their diet. The preparation method matters here enormously because it is not the muscle meat of the pig that formed the primary protein contribution to the Okinawan plate. It was the connective tissue, the tendons, the skin, the cartilage, the bone, slow-cooked for hours in broths and stews until the collagen contained in those tissues was broken down into gelatin and released into the cooking liquid. This broth, rich in glycine, proline, and hydroxyproline, the amino acids that form the backbone of collagen, was consumed as part of the meal, not discarded as waste. This matters biologically in a way that most Western nutritional frameworks do not account for. Collagen is the most abundant protein in the human body. It forms the structural scaffolding of arterial walls, cartilage, skin, tendons, ligaments, and the extracellular matrix that surrounds and supports every organ. After 60, the body's capacity to synthesize new collagen declines. The collagen that exists begins to stiffen and cross-link in ways that reduce tissue elasticity. Arterial walls become less compliant. Joints deteriorate. Skin loses its structural integrity. The extracellular matrix becomes less capable of maintaining the environment that cells require to function properly. Dietary glycine, the primary amino acid in collagen, and one that the body cannot synthesize in sufficient quantities from other food sources as we age. Directly supports the body's ability to maintain and repair this structural collagen. A diet consistently low in dietary glycine, as most modern Western diets are, withdraws one of the essential substrates the body needs to maintain its structural integrity after 60. The tofu that accompanied pork in the traditional Okinawan plate served a different but complementary function. Tofu is a complete protein source. It contains all 9 essential amino acids, and it is the primary protein that supported muscle maintenance in elderly Okinawans whose pork consumption, measured in traditional dietary surveys, was far smaller in quantity than the protein portions typical of Western meals. Tofu also contains isoflavones, genistein, and daidzein, which modulate estrogen receptor signaling in ways that reduce systemic inflammatory burden and support bone density. In the context of a diet where the glycemic environment is already managed by purple sweet potato, the anti-inflammatory contribution of soy isoflavones compounds the overall reduction in inflammatory load that the Okinawa plate produces. Together, small quantities of slow-cooked pork providing dietary glycine for structural collagen support, and tofu providing complete protein with anti-inflammatory isoflavone activity. The protein layer of the Okinawan plate addresses 2 of the most clinically significant processes of aging after 60. The deterioration of structural tissue integrity and the loss of muscle mass. Without the saturated fat load, the heme iron excess, and the advanced glycation end products that come with the large servings of muscle meat that characterize Western protein consumption. For practical application in a Western context, this translates to using small amounts of slow-cooked pork, bone-in preparations braised for hours with the cooking liquid consumed, as flavoring and broth base rather than as a primary protein serving, while making firm tofu the dominant protein source of most meals. The third component of the Okinawa plate that I want to address is one that most people outside of Okinawa have never encountered in a clinical or nutritional context. And it is, in my assessment, one of the most pharmacologically significant vegetables in any traditional dietary system I am aware of. That vegetable is bitter melon. Known in Okinawa as Goya, and eaten there in a frequency and quantity that is unusual even by Japanese standards, Goya shampuru, a stir-fry of bitter melon, tofu, egg, and pork, is so deeply embedded in Okinawan food culture that it functions as something close to a daily meal for many traditional households. For someone encountering it for the first time, the taste is startling. It is intensely bitter in a way that has no close equivalent in the Western vegetable repertoire. But the biological activity of the compounds responsible for that bitterness is the reason this vegetable belongs in any serious discussion of Okinawan longevity. Bitter melon contains 3 compounds that act on glucose metabolism through mechanisms that are distinct from dietary fiber and distinct from the glycemic effects of low-sugar foods. The first is charentin, a steroidal glycoside that has been shown in multiple studies to lower blood glucose levels by stimulating glucose uptake in muscle and fat cells independently of insulin. The second is polypeptide P, sometimes called plant insulin, a compound that mimics the action of insulin at cellular receptors and can directly reduce blood glucose in ways that parallel the mechanism of pharmaceutical insulin sensitizers. The third is vicine, a compound that affects glucose metabolism through additional pathways that researchers are still characterizing in detail. What these 3 compounds produce together, consumed as whole food in the quantities present in a traditional Okinawan meal, is a measurable dampening of post-meal blood glucose, not through slowing digestion, but through actively improving the efficiency with which cells take up and process glucose from the bloodstream. For someone over 60, whose pancreatic beta cell function has already declined and whose insulin sensitivity has already decreased, this active glucose-clearing mechanism is clinically significant. The purple sweet potato reduces the glycemic load of the meal. Bitter melon actively improves the cellular response to whatever glucose does enter the bloodstream. These 2 foods are not redundant. They address glucose regulation through different biological mechanisms that operate simultaneously and reinforce each other. The practical challenge for Western audiences is that Goya is not widely available outside of Asian grocery stores. In cities with significant East Asian or South Asian communities, it can usually be found fresh in season and pickled or preserved year-round. For areas where Goya is genuinely inaccessible, the closest functional substitutes in terms of blood glucose modulation are berberine-containing foods, particularly barberry and golden seal, which share some mechanistic overlap with charentin, and foods high in the compound memorticin, which is also present in certain varieties of cucumber and melon in smaller concentrations. These are partial substitutes at best. The full biological activity of bitter melon is not replicated by any single Western alternative. But the principle of including a food at every meal that actively improves cellular glucose uptake, rather than simply avoiding foods that raise glucose, is the practical takeaway that can be applied regardless of specific food availability. Now I want to address a component of the Okinawa plate that is often discussed in broad terms: fermented foods, gut health, probiotics, but that is rarely examined with the clinical specificity the subject requires. Because the fermented elements of the traditional Okinawan diet are not interchangeable with the commercial probiotic products that most Western health consumers are familiar with. And the distinction matters for understanding why the Okinawan gut ages differently from the Western gut. The primary fermented element in traditional Okinawan diet is miso, specifically a variety of Okinawan miso that is darker, more intensely fermented, and longer aged than the lighter miso varieties common in mainland Japanese cuisine. This longer fermentation produces a more complex microbial profile, a higher concentration of bacterial metabolites, and a greater density of the short-chain fatty acid precursors that support intestinal barrier function in the aging gut. A second fermented element specific to Okinawan culture, and one that is rarely discussed in Western longevity literature, is awamori, a distilled spirit made from long-grain rice that has been a traditional part of Okinawan culture for centuries. Traditional consumption of awamori was small in quantity and slow in pace, consumed with meals, not separately, in amounts that in the context of the full dietary pattern appear to have had a modulatory rather than damaging effect on gut and vascular biology. I mention this not as a recommendation for alcohol consumption, but as a clinical observation about how this element has functioned within the overall dietary system. The mechanism I want to focus on here is intestinal barrier integrity, because it is the mechanism most directly relevant to the systemic inflammatory profile that distinguishes elderly Okinawans from aging populations in the West. As I described in a previous discussion on gut health, the intestinal lining becomes more permeable with age. Gaps form between the epithelial cells that line the gut wall, allowing bacterial fragments and inflammatory compounds to enter the bloodstream. This increased permeability is a primary driver of the chronic low-grade inflammation, the slow biological fire, that underlies cardiovascular disease, cognitive decline, metabolic deterioration, and accelerated immune aging. Fermented foods containing live cultures and their metabolic byproducts directly support the maintenance of the intestinal barrier by feeding the beneficial bacterial populations, particularly lactobacillus and bifidobacterium, that produce butyrate, the short-chain fatty acid that is the primary energy source of the colonocytes forming the gut lining. The critical distinction between traditional Okinawan miso and commercial miso products sold in Western supermarkets is pasteurization. Most commercial miso is pasteurized after production to extend shelf life and standardize flavor. Pasteurization kills the live cultures. What remains is the flavor and some of the nutritional content of the miso, but not the living microbial community that produces the gut health benefits. For practical application, the miso consumed should be unpasteurized, labeled as containing live cultures or as traditionally fermented, dissolved in warm but not boiling water to preserve the live organisms, and consumed daily as part of a regular meal, not occasionally. This is not a difficult habit to establish. A small bowl of properly prepared miso soup requires 3 minutes of preparation and delivers a consistent daily dose of fermented substrate to the gut. The fifth layer of the Okinawa plate is one that I have addressed in other contexts, but that has a specific Okinawan character worth examining separately. Because Okinawa produces a variety of seaweed, mizuku, that is not found in significant quantities anywhere else in the world, and that has been studied specifically in the context of Okinawan longevity research in ways that generic discussions of seaweed consumption do not capture. Mizuku is a thin, brown seaweed with a distinctive slippery texture that is consumed in Okinawa in quantities that are unusually high even by Japanese standards. It is eaten raw, marinated in vinegar, as a side dish accompanying most meals. And the reason it deserves specific attention in this context is its fucoidan content. Fucoidan is a sulfated polysaccharide, a complex carbohydrate with a sulfate group attached, that is found in brown seaweed, but is present in mizuku at concentrations that are among the highest recorded in any naturally occurring seaweed variety. Fucoidan has been the subject of substantial research in Japanese medical literature, and the findings are consistent across multiple study formats. It inhibits the adhesion of inflammatory cells to vascular walls. It suppresses specific pro-inflammatory cytokines. It has anticoagulant properties that reduce blood viscosity and thrombotic risk, and it modulates immune function in ways that appear to reduce the chronic immune activation that characterizes the aging process in Western populations. The broader mineral contribution of seaweed in the Okinawan plate, iodine, magnesium, selenium, zinc, calcium, operates through the mechanisms I have described in other contexts. Iodine supporting thyroid function and the metabolic rate of every cell, magnesium supporting over 300 enzymatic reactions including those governing blood pressure, blood sugar, and cellular repair, selenium supporting antioxidant enzyme systems that protect cellular DNA from oxidative damage, zinc supporting immune function and protein synthesis. These minerals are largely absent from terrestrial plant foods in the quantities that the aging body requires. And in populations that do not consume seaweed regularly, the slow deficiency of these minerals produces functional consequences: subclinical hypothyroidism, impaired insulin signaling, reduced antioxidant capacity, impaired immune surveillance, that are frequently misattributed to aging itself rather than recognized as the nutritional gaps they are. For practical integration, dried mizuku is available through online retailers specializing in Japanese food products, though it is less commonly stocked than kombu or wakame in Western markets. Dried kombu and dried wakame are more accessible and share the mineral density and partial fucoidan content that make Okinawan seaweed consumption relevant to this discussion. Dried wakame can be rehydrated in warm water in minutes and added to any soup or salad. Dried kombu can be simmered in water to produce a mineral-rich broth that serves as a cooking base. The goal is daily inclusion, small amounts consistently, rather than occasional large servings. Now I want to introduce something that is frequently cited in discussions of Okinawan longevity, but almost never examined with the biological precision the concept deserves. Most people who have encountered the idea of hara hachi biyu understand it as a cultural practice, an instruction to stop eating at 80% full, rooted in Confucian teaching. That framing is not wrong, but it is incomplete in a way that causes people to underestimate what this behavioral pattern actually produces in the body, and why it is not simply a cultural curiosity but a clinically measurable metabolic intervention. Hara hachi biyu, the practice of stopping before satiety is fully reached, produces caloric restriction without caloric counting, without formal dietary restriction, and without the psychological burden of deprivation-based approaches to eating. The average caloric intake of traditional elderly Okinawans, when measured in dietary surveys conducted in the mid-20th century, was substantially below the caloric intake of mainland Japanese adults and dramatically below the caloric intake of Western adults of the same age. Not because of poverty or limited food access, but because the eating behavior systematically limited intake to a level that, in the metabolic literature, corresponds to the range where specific longevity-associated biological pathways become active. The primary pathway is AMPK, adenosine monophosphate activated protein kinase. AMPK is a cellular energy sensor that is activated when cellular energy availability is reduced, which is precisely what happens when caloric intake is below full satiety. When AMPK is activated, it initiates a cascade of cellular responses that include increased mitochondrial efficiency, reduced inflammatory signaling, and, critically, the activation of autophagy. Autophagy is the process by which cells identify, isolate, and break down damaged proteins, dysfunctional organelles, and accumulated cellular debris. It is, in effect, the body's internal cellular cleaning system, and it is one of the most important biological processes in determining the rate and trajectory of cellular aging. After 60, the rate of autophagy declines in most tissues. Damaged proteins and organelles that would previously have been cleared accumulate. In neurons, this accumulation contributes to the pathology of Alzheimer's and Parkinson's disease. In cardiovascular tissue, accumulated cellular debris contributes to arterial stiffening and impaired cardiac function. In metabolic tissue, reduced autophagy impairs insulin signaling and accelerates the development of type 2 diabetes. The consistent, mild caloric restriction produced by hara hachi biyu, practiced every day, at every meal across a lifetime, maintains the AMPK activation and the autophagy rate that a fully fed body progressively loses with age. There is also the insulin dimension. Every meal produces an insulin response. The larger the meal, the larger and more prolonged the insulin response. Chronic high insulin exposure, even in the absence of diabetes, suppresses autophagy through a separate signaling pathway involving mTOR, the mammalian target of rapamycin, which is a growth-promoting signaling molecule that directly inhibits cellular cleaning and repair when nutrient availability is high. Eating to 80% satiety rather than 100% reduces the magnitude and duration of each meal's insulin response, reducing cumulative mTOR activation over time, and sustaining the cellular maintenance processes that high insulin chronically suppresses. In a Western behavioral context, Hara-Hachi-Bu cannot be implemented through calorie counting. It is a behavioral habit that requires developing sensitivity to early satiety signals that most Western adults have been conditioned to ignore. Practical approaches include eating more slowly, using smaller plates, pausing for 2 minutes midway through a meal before deciding whether to continue, and establishing a consistent meal rhythm that does not involve eating past the point of comfortable fullness. The mechanism is real and the benefit is measurable. The practice does not require Japanese cultural context. It requires behavioral consistency. Beyond what is on the Okinawa plate, there is something about how elderly Okinawans have always used their bodies in daily life that does not appear in nutritional research, but that I consider clinically inseparable from the dietary pattern I have been describing. It is not exercise in the Western sense. There are no gyms in this picture, no structured training programs, no deliberate athletic effort. It is something both simpler and, from a biomechanical perspective, more demanding than anything most sedentary Western adults currently do in a day. Traditional Okinawan daily life, particularly for the generation now in their 80s and 90s, was built around floor-level living. Meals were eaten seated on the floor. Sleep was on floor-level bedding. Socializing occurred in rooms where chairs were not the default. Domestic work, cooking, cleaning, gardening, was performed in postures that required full hip flexion, knee flexion, and active use of the large postural muscle groups that Western chair-based living systematically underuses and gradually allows to atrophy. The specific movement that I want to address is the act of lowering to the floor and rising from the floor without support. Because this single movement, performed dozens of times each day in a traditional Okinawan household without conscious effort and without labeling it as exercise, demands a level of lower limb strength, hip mobility, ankle dorsiflexion, and neuromuscular coordination that is, for most Western adults over 60, already significantly compromised or completely lost. Studies examining the ability to sit and rise from the floor without using hands or knees as support have found this capacity to be a remarkably accurate predictor of all-cause mortality in middle-aged and older adults, more predictive than many standard cardiovascular risk markers. The reason is not mysterious. This movement requires the integrated function of virtually every major muscle group and joint in the lower body, along with the balance and proprioceptive awareness that prevent falls. When this capacity is lost, it signals a level of functional deterioration across multiple systems that is associated with dramatically increased risk of adverse outcomes. Elderly Okinawans who maintained floor-level daily living throughout their adult lives did not lose this capacity. Not because they were genetically gifted, and not because they performed targeted exercises to maintain it, but because their daily environment demanded it of them consistently without interruption across decades. The neuromuscular pathways required for this movement were used every day and therefore maintained every day. In contrast, a Western adult who has been living in chairs on elevated beds and in environments that require no hip or knee flexion beyond the 90 degrees of sitting will find, at 65 or 70, that the capacity to lower to and rise from the floor has diminished to the point where it feels unfamiliar, uncomfortable, or impossible, not because of disease, but because of disuse across decades. The practical application does not require purchasing a floor cushion or redesigning a home. It requires deliberately introducing floor-level positions into daily life in small, consistent increments. Sitting on the floor for 15 minutes each evening while watching television. Performing one daily task, stretching, reading a phone call from a seated floor position. Practicing the lowering and rising movement specifically, slowly, with control, using a wall or chair for safety initially and reducing that support progressively over weeks. These are not dramatic interventions. They are the reintroduction of a mechanical demand that the body has always needed and that modern Western environments have systematically removed. The neuromuscular adaptation that results, the gradual return of hip mobility, the strengthening of the posterior chain, the recalibration of balance and proprioception, is not fast. But it follows the same logic as everything else I have described in this video. It compounds with consistency in a direction that is measurable and clinically significant. I want to close this section of the video by being precise about something that I think is essential to understanding why the Okinawa plate matters, and why presenting it as a list of individual superfoods, as most popular health content does, fundamentally misrepresents how it works. The cardiovascular markers I found in those patient files in Okinawa, the kidney function readings, the cognitive assessments, the inflammatory profiles of people in their 90s that resembled those of people in their 50s. None of those outcomes were produced by any single element of the Okinawan dietary pattern. None of them were produced by purple sweet potato alone, or by bitter melon alone, or by seaweed alone, or by any single behavior practiced in isolation. They were produced by a system, by the daily, consistent, decades-long operation of a complete biological pattern in which every component performs a specific function and in which each component's effectiveness depends on the presence of the others. The purple sweet potato manages the glycemic environment. It reduces the insulin exposure and vascular glycation that accelerate aging at the cellular level. But the bitter melon operates through a different mechanism at the same problem. It actively improves cellular glucose uptake through insulin-independent pathways, so that the glycemic management produced by the sweet potato is reinforced at the cellular level by a food that works through an entirely different biological route. Remove the bitter melon and the glycemic protection is partial. Remove the sweet potato and the bitter melon is working against a background of high glycemic load that overwhelms its capacity. The miso and fermented elements maintain the gut barrier that prevents inflammatory compounds from entering the bloodstream. But the prebiotic substrate that the beneficial gut bacteria require to produce the butyrate that maintains that barrier comes, in significant part, from the fiber in the purple sweet potato and the polysaccharides in the seaweed. The fermented food and the prebiotic food source are not two separate interventions for gut health. They are two parts of the same intervention, the probiotic bacteria and the food they need to survive and function. Remove either one and the gut health benefit is reduced. The tofu provides the complete protein that maintains muscle mass. But muscle mass is the primary site of glucose uptake in the body, meaning that the muscle preserved by the protein layer directly amplifies the glycemic management produced by the sweet potato and the bitter melon. A sarcopenic body, one that has lost significant muscle mass through decades of inadequate protein intake, cannot clear glucose from the bloodstream as efficiently as a body with well-maintained muscle, regardless of what carbohydrate source that body consumes. The protein component and the glycemic component are not independent. They operate as parts of the same metabolic system. The seaweed delivers the iodine that supports thyroid function, and thyroid function regulates the metabolic rate of every cell in the body, including the cells involved in gut lining repair, immune surveillance, and muscle protein synthesis. When thyroid function is adequate, all of the other biological processes I have described operate at the rate the body needs them to. When thyroid function is suppressed by iodine insufficiency, those processes slow, and the effectiveness of every other dietary element is reduced. The seaweed is not a supplementary element. It is maintaining the metabolic infrastructure that allows everything else to function. The eating behavior hara-hachi-bu controls the total insulin and mTOR exposure across each day, sustaining the AMPK activation and autophagy rate that cellular maintenance requires. But it does this in a body whose glycemic environment is already stabilized by purple sweet potato and bitter melon, whose gut barrier is maintained by fermented foods and prebiotic fiber, and whose muscle mass is preserved by consistent protein intake. In a body where the glycemic environment is unstable, where the gut is inflamed, and where muscle mass has already deteriorated significantly, the caloric restriction produced by hara-hachi-bu produces a different biological outcome. Less effective, less comprehensive, operating against a background of existing biological disruption that the other elements of the pattern are not present to counteract. And the movement, the floor sitting, the gardening, the daily walking, the habitual engagement of the large muscle groups, maintains the physical structure within which the nutritional environment the plate creates can actually produce its effects. A body that cannot move independently, that has lost the hip mobility and lower limb strength that floor-level living preserves, is a body in which the anti-inflammatory, glycemic stabilizing, tissue-maintaining effects of the Okinawa plate are operating within a structurally compromised system. The movement is not separate from the diet. It is what the diet is maintaining the body to be capable of. This is the complete picture of what the clinical data from Okinawa actually shows. Not a list of foods, not a collection of individual habits. A biological system, one that has been operating in the bodies of the people I examined those files for across the entirety of their adult lives. 7, 8, 9 decades of consistent daily patterns, each reinforcing the others, each depending on the others, producing outcomes in the body that no single intervention, no supplement, no pharmaceutical, no isolated dietary change has been able to replicate in the research literature. What I have described in this video is the nutritional and behavioral foundation of that system. It is real, it is documented, and it is available to anyone willing to understand it as a system rather than as a checklist. But there is a layer beyond the plate, beyond the food and the eating behavior and the floor-level movement. A layer that has to do with the social environment in which these patterns were maintained, the community structures, the purpose-driven daily life, the sleep patterns of people who did not own alarm clocks, and what these variables do to the inflammatory and hormonal environment in ways that interact directly with the dietary foundation I have just described. That is where this goes next. And it is the part of the picture that changes the way you understand everything else.